Good morning, Miss Shaina.
Morning.
Hi, teacher.
Hi. How are you?
I'm good.
Fine.
I'm good.
That's good. Okay, we'll just wait for the rest to come and then we'll start. Today we're going through this worksheet, yeah, the one that you all got. Okay?
Yeah.
We'll go through that. Just give me a moment, yeah?
So can I go wash my face? Huh?
Sorry?
Can I go wash my face?
Go.
Morning, Miss Shaina.
Morning.
Morning, Miss Shaina.
Morning. Morning. Okay, can you see the board clearly?
Yeah, sure.
Yeah, okay. Okay, let's just quickly take attendance. Okay. Did you all have issues coming into class today, or did you all have to re-register, or you all could just join?
I just looked at my email. That's only the 8th until the 8th of June, but I just used that one.
And then can come in.
Yes.
Oh, can. Okay. Or some had to re-register. Okay. Okay. Ashira here. Ashira not here. Kurt.
Hey, teacher.
Yeah. Anna here.
Here.
Jada. Jada here.
Pupuk ipapasya ko.
Huh? Jada not here. Mark.
Yeah, sure.
Silver.
Here.
Ashley.
Teacher.
Okay, Jacob. Jacob, are you here?
Teacher.
Cyrus.
Teacher.
Akshara.
Here, teacher.
Kristen.
Here.
Sujit. Sujit.
Just connecting to audio.
Sujit, are you here?
Teacher.
Tirendran.
Kiran and Shiva are together.
But none of them are here. Okay, never mind. Adan. I don't know. Adrian.
Here.
Aiden. Rajan not here. Siddharth.
Teacher.
Kendrick. Kendrick not here. Jada.
Here, teacher.
Quite a few of them not here. Give me a moment. Okay. Okay. Okay, Bryden is here. Bryden, no, Kendrick. Okay.
Kendrick's name is there.
Kendrick, can you hear me? Cannot. Bryden, can you hear me?
Kendra.
Bryden, okay. Kendrick?
Yes, I'm here.
Okay. So only Ashira, Caitlin, Tirendran, and Ada not here. Okay. Okay, so today we're going to do the worksheet that you all got from last week, the one that was collected by your parents. Okay,
So
so
can I go get it?
yes, please go and get the worksheets if you don't have it with you yet. You're looking at energy efficiency, yeah? Can you all see the board clearly? Can see the writing?
Yes.
Yeah, sure.
Okay, let's look at question 1. A kettle uses 1200 joule of electrical energy. Okay. Now, how much is used to heat the water?
I have the
Yes?
I have the other worksheet, but I don't know which is the physics one.
This one?
Okay, I'll try to find it.
Okay. Used to heat the water is 900 joule. Is that useful or wasted?
Full.
Useful energy.
Because this is a kettle.
Useful, cher.
And then loss to surrounding,
Wasted, cher.
that would be how much?
200.
300.
200. Okay. So, have you all drawn the Sankey diagram?
Yeah.
Yes, sure.
No, sir.
Those who are done, please. Those who are not done, please draw now. You were supposed to do it so that we can discuss in class. But those who have drawn, can you please turn on your camera and then show me? Okay, I see Jada's one. Okay, I see
Can you see mine?
Mark's one. Okay, if I mention your name already, you can put it down. Nashley, yes, I can see yours. Kurt, I can see yours.
I found it.
Yours. Tristan, no, Tristan, you have to draw the diagram. Okay, we'll look at it. Siddharth, have you done?
No, I didn't do.
Please do now.
Okay.
Oh, Adan is here. Adan, are you here?
Yes.
Okay. Akshara, can I see yours? Okay. Silver, okay, I see yours. Kendrick, okay, I've seen yours. Sujit? Jada, okay.
Actually, sir.
Okay, please do. Those who are not done yet, please do now. Cyrus, can I see yours?
Yeah, didn't do.
Quickly do, quickly do. You're supposed to do before class so that we can discuss.
So was mine correct?
Jada, is that Jada?
Yeah.
Can I see again?
Okay.
Yes. But what you have to do is the downward arrow, you have to bring it to the right a bit, but it's okay, you have the concept of it, so okay.
Okay. Mine correct was sure.
So question number 1, right?
Sure, I copied the one on the board, sure.
Oh, you have to draw the diagram, you have to draw the Sankey diagram.
So for question number 1, right? Sankey diagram.
Yes.
Teacher?
Yes.
Teacher? Is mine correct?
Can I see yours? Yes. Yeah, it's correct.
Okay.
Okay, let's look at it, yeah? Let's see how to draw. You start off with 1200 because that's the source of energy. 1200. And this is 1200 joule is what energy? What type of energy?
Input.
Electrical.
So electrical energy. And then 900, which one is more, useful or wasted?
Useful.
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 The arrow for useful will be bigger. And useful energy is always to the right. Wasted energy is always pointing towards the bottom. So useful energy is always to the right and the arrow is bigger than the wasted energy. Wasted energy has a smaller arrow compared to the useful. Okay, so useful.
Teacher. Is this correct?
Yes. Make sure you write the correct. That is correct. But make sure you write the type of energy there also.
Yeah. I wrote that.
So 900 is thermal, and then 300 is heat loss to surrounding, right? Thermal also. Okay, so you should have something that looks like this. Okay. Now, how many joules does each square represent? That one no need to do. Please cut that question off. Go to question 2. Calculate the efficiency of the kettle and show your working. So to calculate efficiency, you look at the formula at the top of the paper. It says you put in the useful energy. What is your useful energy?
Electrical.
Yeah, how much?
1,200.
No?
900.
Over the total energy. What is the total energy?
1,000.
1,200. So 900 over 1,200 times 100%. Okay? So 900 over 1,200 times 100%. Okay? And then I can cut off side and side. And then 900 times 1 is 900 divided by 12. What is 900 divided by 12? I can divide by 3. I can simplify by times table 3. So it's 300 over 4. 300 over 4, if you calculate, I have 75%. So the kettle is 75% efficient. Did you all get 75%?
Yes.
Yeah, you should get 75.
Yep.
So you take the useful, 900, over the total, which is 1,002, and then I times 100%. The formula is given up here. Okay. Everyone okay so far?
Yeah.
Yeah?
Yeah, sure.
Anyone still copying? Please raise your hand, if not I will erase.
Done. 14.
Oh, some still copying. Okay, I'll give you all another 2 minutes.
Teacher,
Once you're done, please try the next question. Yes?
can I go to the bathroom?
Yes. The rest of you can look at question 2.
Teacher,
Yes.
did you call me?
Okay, anyone still copying?
No.
No, all done. Okay. Let's look at question 2. Okay. Question 2. We have a toaster. What is the source of energy, the total energy?
1500 joules.
How much is useful?
300 joules.
Okay, that is to toast the bread, so that will be thermal. How much is wasted?
1200.
Yeah, so 1005 minus 300, so 1200 is wasted. Now, if it's wasted, what form would it be wasted? Think of a toaster. The heat is to toast the bread. What is something else that you can observe from a toaster?
Light.
Light,
Sound.
sound, yeah. So those are wasted. Light and sound, you don't need that to toast your bread. What? So light and sound energy will be your wasted energy. Okay, so 1200 is wasted. Now, if you look at these numbers, out of 1005, only 300 is used for the bread. So, is it considered an efficient or inefficient toaster?
It's not efficient
Inefficient, chef.
because it wastes so much energy.
Correct. The wasted energy is so much more compared to the useful energy. That's why it's more inefficient. Okay, so for question 1, how much energy is wasted and where does it go? So 1200 joule is wasted, and where does it go? It goes to sound and light. Or sound or light, like you can pick one. Okay, and then quickly draw the Sankey diagram for the toaster. Start off with 1500 electrical. Now, yes?
Yes, now?
Huh?
What question are we now on?
2.
Okay.
Okay, now, between useful and wasted energy, which arrow will be bigger now?
The wasted one.
Wasted.
So the useful energy will be so much more smaller compared to the wasted one. Okay. So my useful will be smaller and my wasted will be so much bigger. But wasted is always down, whether it's big or small, it's always down. And useful is always to the right. And then put your values in. Okay. So I must be able to see the difference in the size. When you draw the different sizes, don't draw one is 2 cm, one is 4 cm. The difference is so small. Make sure I can see, okay, this is smaller and this arrow is bigger. It must be significantly different. Okay, and efficiency. What is the efficiency of the toaster? What did you all get when you calculate?
So I got 20%.
20%.
Yes.
30%.
What is the working?
300 joules over 5,000 1 times 100%.
100.
I can always cancel up and down, or sideways. down and down now. This is over. So down and down. 1, 5, yeah, 20%. The efficiency is 20%.
But sure, I got my answer. I already canceled the 1,500 zeros and left the 300 zeros.
You can't cancel this with which one?
I canceled the 2 zeros for the 1,500, but I left the 2 zeros for the 300.
You cancel with which one? If you cancel here, you must cancel somewhere else also. If you cancel down, you either cancel at the top here with the 100 or with the number at the top. Either one.
I canceled 1,500 zeros with the 100.
Yeah, can also.
Okay.
This one or the up one? Lah. Always remember when you cancel, is down number with up number or down number. This is considered up also because over 1.
Okay, teacher.
You cannot down and down like this. Cannot. If let's say there was 100 down here, cannot cancel like this.
Okay.
So your efficiency is 20%. So this is considered a low efficient toaster. The kettle just now 70%, 75 is considered high efficiency. Okay, can I see a show of hands of those who are still copying? Good, all done. Then let's go to question 3.
Can I go back?
Can.
That's for question 2I. What was the answer for 2I?
So if 300 is useful, how much is wasted?
Oh,
If 1005 is total and 300 is useful, then wasted is how much?
1,200.
Yes. And where does it go? It goes to sound or light.
Yeah.
Yes.
Can I go to the bathroom?
Okay, why don't you all take a quick break? Those who want to go to toilet, quickly go and drink water. Come back in 5 minutes.
So what are we doing now?
Okay, is everyone back?
Yes. Yep.
Okay, let's look at the next question, question 3. Question 3, what is the appliance that they are looking at?
Microwave.
They're looking at a microwave. What is the input energy, the total input energy?
400 joules.
400.
No, input energy, the starting energy. 400 joule of energy is to cook the food. So that is useful energy to cook the food.
So no useful energy.
There's no
It shows 400.
Give us efficiency of 8.
So we know that it has electrical energy and it has an efficiency of 80%. Okay? So if 80% efficiency means the 80% is, that means when I take the input energy over the total, which I don't know what the total is, and then I times by 100, I get, what is the question?
80%.
Sorry?
80%.
80%. So they say that the efficiency is 80%, which means when I take 400 divided by the total, which in this case I don't know what the total is, and then I times by 100, I will get 80%. So what is this further here? What is the total here? So I use normal maths, 400 times 100% divided by, I don't know what is my total, so I put it as x. And this is 80. So how do I solve this?
One times 100 first.
Okay, which is 40,000.
400.
400,000. And this is 80. So I bring the x,
Divide.
divide, this is divide x. I bring to the other side, becomes times x. So 400,000 and 40,000 is equals to 80x. Then I just switch the other side, right? It's the same thing. And then what is 1x?
40,000 divided by 80.
40,000 divided by 80. Up and down, I can cancel 1 0 with 1 0. I got no more zeros to cancel with the bottom. So 4,000 divide 80, divide 8.
500.
500. That means my input energy, my total at the start is 500.
500 joules.
So if 500 joule is my input energy and 400 is useful, what is my wasted?
100.
100.
Okay. So if you all didn't do this, please copy this one. In order to get your answer 500, please copy this working. Does anyone not understand what's happening here? No, all okay. Okay, copy first, then we will go on to drawing.
Teacher, where should I write in the square box?
I know, don't write in the square box, right outside lah, at the side. Because the square box you want to draw. Okay, and then if you're done, you can start trying to draw the Sankey diagram. Okay, those who are still copying, can you please raise your hand? If not, I'll erase this part to draw the Sankey diagram.
I'm done.
Now you're done almost.
Huh? Now you're done. Jacob, are you done?
Not.
Not yet. Okay, I'll give you another 1 minute and then I'm going to erase it, okay? Okay, I'm going to erase, yeah? Okay, now please draw the Sankey diagram. Which arrow is bigger, the one to the right or the one going downwards?
The one to the right.
The one right.
Right.
Because useful energy is more.
So when we draw Sankey, right?
Sorry?
When we draw like the Sankey diagram, must we draw it pencil?
Yes.
Okay.
What is the useful energy?
Electrical energy.
That is the input.
100.
You heat the food, what energy?
Heat energy.
Yeah. And then what is my wasted energy?
Mm,
What?
sound.
Light.
Sound.
Light energy.
Some more? My some more?
Sound.
Sound.
Okay, if you're done with this, please go to the fourth question. Hair dryer. Okay, let's look at the last one, hair dryer. Okay, hair dryer, what is the input energy?
1200.
Okay, what is the type of energy?
Electrical.
Okay. Okay, Sujit, what is my useful energy for the hair dryer?
Your useful energy for the hairdryer.
Yes. How much?
Form of useful energy is air.
No, what is the amount?
100 joules.
Sorry?
100 joules.
No, what does the question say? A hair dryer is 100 joules of electrical energy. The useful transfer energy is how much?
600 joules.
Okay. To dry your hair, what type of energy you need?
Heat and air. Thermal.
Thermal.
This is my useful. Okay, what is the... So it usefully transfers 600 joules to dry the hair. And then 500 of the useful energy is used to heat the air. So 500 out of the 600 is used to heat the air around. Okay? Now, what are other forms of useful energy?
Electrical.
No, electrical is the source.
Oh,
What are other forms of useful energy in this case for the hairdryer?
Like when the heat is one thing, the air that comes out of it.
But the air is not energy, what? What type of energy would be useful other than thermal energy?
It has a cool energy, like the hair dryer has hot, and then you can choose.
and it's cold.
Like
Yeah,
cold air?
cold.
So what type of energy is that?
I'm not to call cool energy.
Potential energy. Acha.
Potential? Why potential?
Kinetic energy.
Why kinetic energy?
Because the air
Sorry?
is blowing the air in our face on our head.
Wait, can you repeat that? I can't hear you.
The hair dryer is blowing the air is on our head. So it's a kinetic because the air is moving to our face or to our head.
So what is inside the hair dryer that causes the air to move?
Air sucker.
No, there will be a fan, like a fan.
Motor.
Yes. So
Chemical energy.
for the motor, we need kinetic energy. So another useful energy will also be kinetic energy. So for I will be other form of useful energy, you can put kinetic. Okay? Now, how much energy is transferred for this? If 500 is
100.
the air, 100 out of the 600 will be used for actually drying the hair, which is kinetic. So for number 2, how much energy is transferred for this? 100 joule. So out of the 600, 500 is for the air, and then 100 is the rest. Now, 100 joule is wasted as sound energy. Okay, now under wasted, if 1200 is useful, so useful is 600, wasted is how much?
500.
Huh?
600.
600 or so.
600.
Because useful is 600, wasted is 600, then 1002. Now, from the 600, again, 100 is wasted as sound. Okay. What are other forms of wasted energy?
Light energy.
Okay. So light energy, and if 100 is sound, from the 600, the light will be what?
500.
500. The remainder, 600, 100 is sound, 500 light. Okay, so that is for number 3. What is the other form of wasted energy and how much? So you can put light and you can say 500 joule. Okay, that is for number 3. And then number 4, draw the Sankey diagram. Okay, so now in this case, useful and wasted is equal. So the arrows will be
Same.
Equal.
same size, huh? Make sure you draw the arrows same size. Because useful and wasted. So if both is also same, without calculating the efficiency, what is the efficiency?
50%.
50%. Half. 1,200 electrical. And another 600 is sound. Make sure the arrow is same size. Huh?
Yes. Harusnya warna.
Okay, so that is for question number 4. Anyone has any questions on that?
No.
No? Okay, if you have no questions, you can take a quick break. It's 12:20 now. Come back at 12:30. Okay? Then we will continue. Yes. Yes, someone call me. Okay. Okay, so I'm going to give you all some questions now. Now, these are questions that are quite generic, quite general. It's not skewed to one topic, but you will need to know, these are basics, and you need to know some basics for your exams and even for life. So, I am going to post the questions on the screen. Okay. Wait, let me just look for it. Okay. Okay. Okay, can you all see the questions?
Yeah.
Yeah, it's okay.
Okay.
Yeah.
So yes, do first, and then we will discuss. Okay. So I'm gonna put the questions here. Yeah. So please start do question 1 to 3 first, and then we will discuss, and then we will continue. Okay. So start doing question 1 to 3 first. Please do it in your exercise book, physics exercise book. Just write the answers. No need to write the questions. Just write the answers.
So write down in the exercise book and do.
Yes, write in the exercise book. No need to write the questions. Just write the answers.
Yeah.
Yes.
What's S mean?
Sorry?
Does S mean?
S, second.
Yeah. Oh, okay. Turn.
Okay. Wait, I will just wait a couple more minutes and then we will discuss. Can I see a show of hands of those who are still doing?
Teacher, it's question 1 to 3, right?
Yeah, 1, 2, and 3.
Okay.
Yeah. Okay, I'll give you a couple minutes more and then we will discuss.
Teacher, you write down the question and also the answer. Only write down the answer only.
No, only the answer.
Answer.
Okay. Let's look at number 1. Which of the following is the unit used to measure mass?
kg.
Hmm?
kg.
kg. The unit used is kg.
E
Unit used to measure time?
S.
S.
Okay, find the area of the rectangle drawn on the right using the measurement given. What is the area?
24
4 times 6.
Before C.
Unit,
24 cm.
24 cm.
no.
24 cm square.
square.
Correct. 20 cm squared. Okay, next. A block of metal measurement shown. What is the volume?
N cm square.
Question 2 again, teacher.
Sorry?
What is the answer for question 2 again?
24 cm squared.
So can I try for question 3?
Yeah.
So is it 10 cm cube?
Yes, 10 cm cube because volume is 3 dimensions. For area, you only multiply 2 dimensions, so cm square. but volume is length times breadth times width, 3 dimensions, so cm cube. Okay? All okay?
Yes.
Yes, sir.
To the next. 4, 5, 6 first. Okay. Quickly do 4, 5, 6.
Wait, what's the answer for question 3?
10 cm.
10 cm cube. 5 times 1 times 2. 10 cm cube. Okay, please do 4, 5, and 6, yeah?
Okay.
So what diagram, sir?
Which question?
Number 4, sir. They're asking if equipment is.
This one.
Oh,
The one at the side.
one. Okay. But there's only one picture.
Huh?
They said name and. Oh, okay. Yeah, never mind.
For number 5 is this diagram.
Okay, sir. Nice.
This one.
So I don't know what is the equipment name for number 5.
What?
I don't know what is the name of the equipment.
Okay, never mind. You continue first, and then you. It's actually so it's the place where you put the Bunsen burner on. Have you all used this in biology experiment? Hmm?
So which one is it? Well, is it that triangle stand thing, or is it that something like a meter to measure? Is it that equipment or the triangle?
No, it's the triangle stand.
Can you say again? You are lagging.
Is that triangle stand? It's the Bunsen burner tripod stand.
Or is the one they're asking to give the piece of equipment shown?
For number 5, yeah.
And for number 4.
For number 4 is this one.
Oh, what is that? Sure, I don't know.
What is this? This is a thermometer.
Oh, I thought I didn't know it was a thermometer. I thought
It's a thermometer. This one is a Bunsen burner. We call it a Bunsen burner tripod stand.
Teacher,
Yes?
so like it's the thing is used to like hold the Bunsen burner.
Yes, correct.
Sure, for number I is it? I put there it helps to hold like the helps to hold stuff like experiment stuff.
It helps to hold the Bunsen burner.
Okay, thank you.
Miss Sheila,
Yes? Yeah.
for this worksheet, you have to get back to you.
No need to give that.
We need to get back.
No need.
If
Yeah, for number 6, right, sir? For 6, 6, number 2, I to wear gloves, sir. Anna.
Can?
Sure, I put the same as Brandon also. I put there use gloves.
Can.
So for the 6, I put to wear the safety goggles.
But he's already wearing what? It says not shown in the photograph.
So for the first one, it is shown in the.
Oh, yeah, can. Yeah, correct.
Sure, for the 6 eye, right? Can I put there not put too close to your eyes?
Can?
Teacher?
Yes, you can.
Okay.
No, actually, I not doing this part. Tomorrow, I'm going to ask. Tomorrow is what subject?
Okay, for the worksheets that we have given y'all don't need to pass it up because we will discuss in class. Okay?
Okay.
Okay, let's quickly discuss. Okay, name and give one use for the piece of equipment shown in the diagram. What is this equipment called?
Thermometer.
Thermometer. And what is the
Thermometer.
To measure heat.
Bunsen burner.
to measure the temperature of a liquid?
Temperature.
To measure temperature. Okay.
To measure heat.
Not to, you don't measure heat, you measure temperature.
Sir,
It's an energy.
I said you check how hot or cold the temperature is.
Can. Like that can. Temperature of a liquid. Right there specifically. Okay, so we can say to measure the temperature or measure how hot or how cold a liquid is. Okay, number 5. The piece of equipment is, it is the Bunsen burner tripod stand. Okay, what it does is it holds the Bunsen burner. Okay, let me just show you. Okay, Bunsen burner tripod stand. Okay, yeah. Okay, so sometimes you put the wire gauze here. Okay, and then some people, they put the Bunsen burner no, actually the Bunsen burner goes below. The Bunsen burner doesn't go on top. Wait, let me look at the picture. Okay, so this one, there will be a wire gauze that is at the top and the Bunsen burner is at the bottom. So it won't be to hold the Bunsen burner in place. Sorry, that's not right. The Bunsen burner goes at the bottom. So you can say the purpose for it is to hold the beaker like this. This is a good picture. So you hold the beaker so that the Bunsen burner can heat it up.
Sure, what is white thing?
The white thing, this is a wire gauze. So because if you don't put, the white thing is part of this wire thing. Let me show you again. So if you don't put that thing on if you don't put this on the tripod, then the beaker will fall through the hole. So that's why you put this. And this wire gauze will help to conduct heat. So the flame that is coming from the Bunsen burner here, it will get transferred to this wire gauze, which is a good conductor of heat, and it will heat up the beaker. Okay, so the purpose of the tripod stand is to hold equipments to be heated by the Bunsen burner. Okay. Let's see if there's another way of writing that. There. Used to support flask and beakers. A wire gauze is placed at the top to provide a flat base for the glassware. Tripods are generally tall enough for the Bunsen burner to be placed underneath. Okay, can you understand? Yeah? So you can say this is used to support flask and beakers so that the Bunsen burner can be placed underneath for heating. Okay, let's look at the next one. Give one safety precaution taken by the pupil shown in the photograph while doing the experiment.
He's wearing safety goggles.
Yeah, he's wearing safety goggles.
Safety
What
glasses.
precaution not shown in the photograph that you would take when heating a substance?
You will wear gloves. You would wear gloves.
To keep a
Wear gloves.
distance.
No? Any other things?
To keep a distance from the source of heat.
Correct. You don't want to stand too near to the
Yeah,
flame.
exactly. So that's why I think you take this
Yeah.
out and you spend outside when you go out.
Also, when you're heating, you cannot just hold the beakers or whatever with your bare hands. You must use test tube holders or crucible tongs, or you must
Gloves.
yeah, even with gloves, you have to, when you're picking up all these hot beakers and all, You have to use equipment to lift them up. Okay, if it's too hot, then you don't want to
Sure,
stir.
Akshara wants to say something.
Yes.
Akshara wants to say something.
Yes, Akshara.
What? No, I didn't say anything.
Oh. Okay. Okay, so that's number 6. All okay so far?
Yeah.
Okay.
Teacher,
Yes.
How many questions are there?
They're all-
so what's the number on top of the questions?
Oh, this one is because these are past year papers, exam questions, the year where the question. Okay, do number 7, 8, 9. 7 and 8 first, because 9 and 10 you can't really see. Do 7 and 8 first.
The one where it shows like the ml, is that a beaker?
The measuring cylinder.
Okay, cylinder. Okay.
Teacher? Teacher?
Yes,
For question 7, what diagram they're talking about?
this one.
Okay.
So done.
Okay, we'll wait a couple more minutes and then we will discuss. Okay, let's look at number 7. Name any 2 items of equipment shown in the diagram. So what do we have here?
Panjambara.
Burner.
Measuring cylinder.
Oh, this was for question 8, but okay, this is a measuring cylinder, correct?
5%.
5%.
Okay. Now, what is the name of the equipment shown here? It is a measuring cylinder.
Measuring
You all
cylinder.
know the difference between a measuring cylinder and a beaker?
Yeah. Yeah.
Yes.
Measuring cylinder.
So measuring cylinder is what we saw just now. It is tall and long like this. And a beaker is like this. Okay? Yeah. And then the test tube is like this. All okay?
Yeah.
Okay. And then let's look at the question. Next question. Name a second item of laboratory equipment which enables more accurate measurement of volume to be made.
Measuring.
The beaker.
Sorry?
I put beaker. I said a beaker.
More accurate measurements.
The beaker.
Beaker.
Anyone else?
How about
Huh?
burette?
Okay, so there are a few. A burette is a very, very good measuring tool. It is more accurate. Why more accurate is because it has more divisions. Divisions mean it has smaller, like this one, the metrics. Like beaker is only 5, 10, 15, 20 like that. But this one is smaller, so 10, 11, 12, 13, 14, 15. So this means more accurate because you can read the scale more.
So Chetan is the answer.
Yeah, burette. Burette. Okay. See, like a beaker, if you look, is 100, 200, 300. So if let's say it's 176, I wouldn't know because they don't have the lines. But then for a burette, they have it, so it will be more accurate. That's why they say it's more accurate. Okay? Okay, please do 9 and 10.
Teacher? Teacher?
Yes.
So for 9, I need the equipment.
The diagram shows a piece of equipment labeled A containing water. Name A. What is A?
So I need the equipment, right?
Yeah, the equipment, yes.
So it's a beaker, right?
No, it's a measuring cylinder.
I thought it was a
Oh.
Yeah.
Beaker is the fat one.
So for 10 iron
Okay.
is a beaker, right, sir?
Is it asking to name the item like the stone inside A?
No, the whether it's a beaker or what. This is actually a water displacement beaker.
So you said just now got measuring cylinder, beaker, and then one more thing, so I didn't hear.
There's a lot. There's measuring cylinder. There is beaker. There is conical flask. There is a burette. A lot of things.
Okay, John. So I can go bathroom.
Can. Okay, let's quickly look at these questions. The diagram shows a piece of equipment labeled A containing water. What is A?
Measuring cylinder.
Measuring cylinder. Okay, a stone was then added and a new volume was recorded. What was the volume of the stone?
90 centimeters. Cube.
Now look at the diagram. The first diagram without the stone, how much was the level? Water level?
75.
5. And then once they
5
put
cm
the
square.
stone in, it went to
90.
15
90.
cm.
So what is the volume of the stone?
15.
15 cm cube.
So 75 to 90 is 15 cm cube. So the volume of the stone is 15 cm cube. Now this method of putting water and then putting an object in, and then you see how much the water level rises, and then that is equal to volume of the object. This method is called water displacement method. So if I have an irregular object, because regular object, let's say cube or cuboid, I can just take length times breadth times width. But if I have an irregular object, like even this potato, to know what the volume of it is, this is what I use. It's called water displacement method. Okay, let me just shift to the whiteboard for a while. So it is called water displacement method. So if I have an irregular shaped object and I want to know what the volume is, I use this method. Okay. So I take a beaker, okay, okay, and then I put water inside, let's say 50 cm cube. I drop the object in, and then because I'm dropping the object in, the water will automatically increase. Okay, so depending on the object. So let's say I like this. So the water level will increase. So your new water level, let's say 76 cm cube. So when I take 76 cm cube with the object inside here, minus 50 cm cube, it's 16 cm cube. So 16 cm cube is the volume of the object. So this method is called water displacement method. Why water displacement? Because, yes?
It's 26, right?
26, sorry, yeah. So why it's called water displacement method? Because water has been displaced. Okay, in this case, let me just share screen again. You see, water has been displaced. Okay, so when I put the potato in, automatically the water increases, and then the extra, in this case, this beaker has an opening. So the extra water is filled up to here. That means the amount of water that it has been filled up is the amount of water that has been used, which is 125 cm cube. So a pupil measure the volume of potato using the items labeled A and B. What is A? A is a beaker. It's a water displacement beaker. So it's a beaker, but it has an opening. Okay, and B is a measuring cylinder. So those are the items. Okay, and what is the volume of the stone? Oh no, volume of the potato. What is the volume of the potato? Anyone?
25.
125, because that is the amount of water that was displaced, the amount of water that was poured out, amount of water that increased when the potato went in. So the potato's volume is 125 cm cube. So that is the amount of water that has been displaced. So it's called the water displacement method. Okay, can I understand?
What's the answer for 10 number?
Yep.
Number 1, A is water displacement beaker, B is measuring cylinder. Okay, I need to go to the washroom really quickly. I will be back. If you need to go to the washroom, quickly go and then come back, okay?
Okay. Okay, ciao.
Okay, are y'all back? Are y'all here?
Yeah.
Let me see. Mark, are you there?
Yes,
Okay, I'll just give a couple more minutes for the rest to come back. And then we will do a little bit more before we end today's class. Okay, let me just.
Can Jeff?
Okay. Okay, so I have energy changes. So these are the types of energy. Okay. Energy is changing from one direction or from one form to another form. Okay, so let's look at the exercise. Write down your answers first, then we will look at the answers. So please write down your answers. The energy changes from what to what. And then we'll look at it together.
sure. So number 3, is it solar energy or light energy? Sure.
You can put solar.
Is it solar or light energy? Number 3.
You can put solar.
Solar energy.
Yes.
So for 2, right?
Number 2, okay.
So for number 2, sir, is it heat plus light, sir?
Yes.
The fire is very bright.
Yes, heat plus light. Number 2, coal. Coal is what energy?
Chemical.
Yes, chemical.
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 For C is chemical.
Which one?
For the
Which one? 1, 2, 3, 4, 5. Which one?
the third one, the calculator.
Yeah.
So for the
Light and
car one, after heat is electrical.
number 3, calculator is light to electrical.
The car one, after chemical to heat to, is it electrical?
No. The chemical from the battery and then heat the engine, and then what happens to the car?
There's kinetic energy.
The car will move.
Kinetic.
Yes.
Number 5, is it kinetic energy? Then it becomes sound because you're moving the.
Yes.
So I don't know number 1, sir. I don't know how to do number 1.
Okay, we'll discuss.
So 5 is what?
You have to move the fork and then it will produce sound. So it's kinetic.
Okay.
Okay, so done.
Chưa done.
Okay, can I see a show of hands of those who are still doing? Let's discuss. Number one, so from the top, the ball is moving down. So at the top is gravitational potential energy. Then it rolls down. So what energy?
Kinetic.
Yes, kinetic energy. Okay, next. The coal is chemical energy and then transforms to heat plus
Light.
Number 3 is light or solar energy to electrical energy. Number 4, chemical to heat to.
Kinetic energy.
Kinetic energy.
And then the last one is kinetic or movement. You can also say movement. To.
Teacher, what is number 2 again?
Number 2 is chemical from the coal transformed to heat and light.
Thank you, teacher.
Okay. Anyone missed anything?
No.
No.
Number 4.
Number 4, chemical to heat to kinetic, because the chemical from the battery and then you on the engine, the heat, and then the car moves, so kinetic.
What's number 3?
Number 3, light energy to electrical energy.
Is it light or solar energy you can put?
Yeah, you can put solar. Okay.
You also put solar. You also put solar.
You can also put solar.
So are we going to do any other exercise? Sure. Are you doing any other exercise?
It is 127. Wait, let me see. Let me see if there's any short ones.
Okay.
Okay, let's do this one, last one. Complete the sentences below. So there is the sun, energy source. Most of the energy on earth comes from the sun. The diagram shows how we can trace energy. Okay, so from the sun, you have solar cells absorb light energy and convert to electrical energy. Plants trap light and store food. Heat absorbs water vapor from the ocean, falls as rain. Heat absorbed by atmosphere causes wind to turn the wind turbines. And then solar panels absorb energy and use it to heat water. So complete the sentences below. Okay, quickly do.
Done.
Okay, I'll give a couple more minutes, maybe 1 minute more, and then we'll discuss.
But I don't know number 4.
Okay, we will see together.
Okay.
Are we going to discuss?
Sorry, what? Okay. Everyone else can hear me. Can you all hear me, or are you all having issues hearing me?
Yes, can you?
Yeah, I can hear you.
I can hear you.
Okay. So let's look at the answers. Okay. The first one. Let me call. Okay, Jacob, try the first one.
Plants absorb the sun's energy to make food.
Okay. Next one. Sujit.
Fossil fuels are formed from dead plants and animals.
Okay. Dead plants and animals. Number 3, Akshara.
Teacher,
4. Number 3. No response. Okay. Okay, next. Number 3.
for number 3,
Yes.
solar panels can be used to absorb heat directly from the sun.
Okay. Number 4, Adrian.
I don't know number 4.
Who knows number 4? Who wants to try number 4?
What's number 4?
No, I'm asking if anyone knows number 4 or not.
Is it cars, Cher?
No.
Solar coal.
Solar cells.
Yeah, I suppose say it's all cells.
Yeah, solar cells. Change light energy into electrical energy. And the last one, winds are caused by
Heat.
Heat. Heat.
the sun. Yeah. So that is all for today. Anyone has any questions?
No, sir, I don't have any questions.
No? Okay. Anyone else? No?
No,
Okay, that is all
Yeah,
for
I have a question.
Question 4.
number 4. Number 4 is solar cells. Ne?
Teacher, I have a question.
Yes?
When will the schedule for our midterms be given out?
Or
already given.
Yeah, it's already given out.
Already given out lah.
It is?
Mm.
the one where it tells what day, what subject.
Yeah.
Yeah.
The email already.
Was the email sent to our parents or to us specifically?
Parents.
Yeah. Okay? Okay, thank you. Bye.
Bye.
Bye, Cher.
Bye.
Bye. Bye.